This lecture is about the difference quotient, so we're going to take a look at how to find the difference quotient for different types of functions. You can do this operation all in one step, or you can break it down into 4 different steps. I'll be doing it by breaking it down into steps, but if you'd like, you can do it all at one time as well. So the difference quotient is f of a plus h minus f of a all over h. So the first step of this is to calculate f of a plus h. So we're going to replace x with a plus h. In the second step, we're going to subtract off f of a. And in the third step, we're going to divide by h. And in the fourth step, we'll simplify. And how we simplify that will depend on what type of function we have. So in our first example, our function is f of x equals 1 minus 5x. Step 1. Step 1 is to find f of a plus h. So we want to replace this x with a plus h, so that will be 1 minus 5. And then the x we're going to replace with a plus h. So I'm just going to put that in red. And now we want to simplify this expression, and to simplify it we want to distribute this negative 5. And so f of a plus h is 1 minus 5a minus 5h. Step 2 is to subtract f of a from what we got in step 1. So from step 1 we got 1 minus 5a minus 5h. And then we're going to subtract off from that f of a. So it's just going to be your function, only instead of an x we'll have an a. So that's 1 minus 5a. Make sure that you put this expression in parentheses because you need to distribute this negative sign. So that will give us 1 minus 5a minus 5h, and then minus 1 and plus 5a. After you complete this step, there should be a couple of things that will cancel out. We have a positive 1 and a negative 1, so that gives us 0. We also have a negative 5a and a positive 5a, so those also cancel. And so after this step, we're left with just a negative 5h. Step 3 is to take the result from step 2 and divide it by h. So that's f of a plus h was what we calculated in the first step, minus f of a is what we did in the second step, and in step 3 we're dividing that expression by h. So the result from step 2 is negative 5h, and we're going to divide that by h. And then step 4 is to simplify this. And so these h's will cancel, and our final result then is negative 5. Okay. And notice that the answer that we got was negative 5. And this function is actually the equation of a line. And the slope of this line is negative 5, which is what we got from our difference quotient. And that is what you should get when you're calculating the difference quotient. So the difference quotient, graphically speaking, this is a calculation that you do in calculus oftentimes. And so if this is the x value for a, and h is some interval, so we have some other x value that's up here, and this distance is h. So this value right here is a plus h. That's the x value right there. And then over on the y-axis, this would be f of a. And bring this one over to the y-axis. This is f of a plus h. So the calculation that we just did was f of a plus h minus f of a, and divided by h. But h is a plus h, this x coordinate, minus a, this x-coordinate. And these a's then cancel and you get h. Okay, but this h really is the same as a plus h minus a. So what we have is on the top, we have the difference of the y's. And on the bottom, we have the difference of the x's. Oops. And that's what we commonly know of as the slope. And it's the slope that connects, the slope of the line that connects these 2 points on this graph. And so that's what we're calculating here. In our next example, so this is a polynomial, it's a quadratic function, and so remember the graph of a quadratic function is a parabola, and so we're going to do the same thing here. So step 1 is to find f of a plus h. So we're going to replace our x with a plus h. So our function is 4 minus 3 times x minus 2 times x squared. And in my parentheses where the x used to be, we're going to put this a plus h. And we want to simplify this expression. So here we need to distribute the negative 3, giving us 4 minus 3a minus 3h. Here you have to follow order of operations. In an order of operations, exponents come before multiplication or distributing the negative 2, so you have to square this a plus h first. So you need to take a plus h times a plus h. This step is really important. So a times a is a squared. Then from here we get an a times h, and here we get another a times h, that's plus 2ah, and then plus h times h is h squared. So we have minus 2 times a squared plus 2ah plus h squared. Once you do FOIL on a plus h squared, then you can distribute this negative 2. So this gives us 4 minus 3a minus 3h minus 2a squared minus 4ah minus 2h squared. And you can't simplify anything in that expression right now, so we'll move on to step 2. And step 2 is to take the expression that we found in step 1, a plus h, and subtract from that f of a. So we have 4 minus 3a minus 3h minus 2a squared minus 4ah minus 2h squared. So this is just the expression that we got from step 1, and then from that we're going to subtract off our function, only instead of x's we're going to write a's, and make sure that we put it in parentheses. So 4 minus 3a minus 2a squared. Now distribute this negative sign. This gives us 4 minus 3a minus 3h minus 2a squared minus 4ah minus 2h squared minus 4 plus 3a plus 2a squared. Now you should have some terms that will cancel in this. We have a positive 4 and a negative 4, so those will cancel. We have a negative 3a and a positive 3a, so those will cancel. And we also have a negative a squared and a positive a squared. So be careful that you catch all of the terms that are remaining. So we have a negative 3h right here. We have a negative 4ah and a negative 2h squared. All of the terms that you end up with in step 2 when you have a polynomial should all have an h in them. And then we need to do step 3. That's to take the expression from step 2 and divide it by h. So what we had so far from step 2 was f of a plus h minus f of a. And we're going to take that and divide it by h. So negative 3h minus 4ah minus 2h squared divided by h. Step 4 is to simplify this. And so we can factor an h out of our numerator. And when we factor the h out, we'll be left with negative 3 minus 4a minus 2h. And then once you do that, you can cancel these h's. So our final answer is negative 3 minus 4a minus 2h. In example C, so we're going to do exactly the same thing. The difference with a square root function is that the simplifying in the end is a little bit trickier, and so we will take a look at how to do that. So our function is f of x equals the square root of 2x plus 3. Step 1 is to find f of a plus h. So that will be the square root of 2, and then a parenthesis for where our x was, and then plus 3. And I always like to put a little bar down after my square root ends. Just lets me know where for sure that square root is ending, so I don't have any question in my mind as to how far that square root symbol is supposed to go. And then in the parentheses goes our a plus h. And the only thing we can do to simplify this is distribute that 2. So we'll get the square root of 2a plus 2h plus 3. Step 2 is to take what we calculated in step 1, f of a plus h, and subtract from that f of a. So that will be the square root of 2a plus 2h plus 3 minus the square root of our function, only instead of an x we'll write an a, 2a plus 3. Step 3 is to take our expression from step 2 and divide it by h. F of a plus h minus f of a, all of that being divided by h. So 2a plus 2h plus 3 minus the square root of 2a plus 3. All of this divided by h. Now step 4 is to simplify this. And what we need to do is we need to get rid of the square roots in the numerator so that we can cancel with this h down in the denominator, because you can't leave the h in the denominator. Simplifying this expression means getting this h out of the denominator, because when you use this in calculus, you're going to end up replacing your h with 0, and dividing by 0 is undefined. So we can't end up with an h in our denominator. So the way that we can get rid of our square root is to multiply by the conjugate. So just over here on the side, I want to talk about that for a minute. The conjugate of something is, of a binomial, is the binomial except for you change the sign in the middle. So the conjugate of a plus b would be a minus b. And when we multiply conjugates together, what happens? A times a is a squared. And then here you get a negative ab. And then here we get a positive ab. And so those two cancel out and give you 0. And then positive b times negative b is minus b squared. So when we multiply our conjugates together, we're going to get a squared minus b squared. So this square root is going to be our a. This square root is going to be our b. And when we square the square roots will cancel with the squaring. And so we'll get rid of our square roots like we want to do. So we're going to take this expression and multiply it by the conjugate of the numerator, which is just going to be the numerator, only change the sign in the middle. So we're going to multiply it by 2, the square root of 2a plus 2h plus 3. And then minus the square root of 2a plus 3. Oops, sorry, that should be plus because we want to change this sign in the middle. And then do the same thing in the denominator. Multiply by the square root of 2a plus 2h plus 3 plus the square root of 2a plus 3. So when you do that multiplication then, and you can do FOIL on this if you want, but you can also use this formula if you'd rather. So the formula says that you square this square root, and when you square this square root, the square and the square root basically cancel each other out. And I'll just write this out here. So it would be the square root of 2a plus 2h plus 3. That thing's squared. And then there's always a minus sign in between these, and then you square this. So the square root of 2a plus 3 squared. And this is all over h times the quantity square root of 2a plus 2h plus 3. And then plus, so there's a plus sign here, the square root of 2a plus 3. And you don't want to distribute this h. You want to leave it just like that for right now, because our goal is to try to cancel this h out in front. So when we square this square root, what we end up with is 2a plus 2h plus 3. And then we have this minus sign. And then this, you need to make sure you leave in parentheses. When you square this, you're just left with a 2a plus 3. And then this is all being divided by h times the quantity square root of 2a plus 2h plus 3 plus the square root of 2a plus 3. Now we can distribute this negative sign. That gives us 2a plus 2h plus 3 minus 2a minus 3. And don't forget your denominator, h times the quantity square root of 2a plus 2h plus 3 plus the square root of 2a plus 3. The 2a and the negative 2a cancel, the 3 and the negative 3 cancel, so we're left with 2h over h times the quantity square root of 2a plus 2h plus 3 plus the square root of 2a plus 3. So now you can cancel this h and this h, and your final answer then is 2 divided by the square root of 2a plus 2h plus 3 plus the square root of 2a plus 3. So there still is this h down in the denominator, but when we replace this h with 0, it's not going to cause us to divide by 0 like this h would. So this h is okay because replacing this h with 0 won't cause us to divide by 0 with this expression. And so there's our final answer for that one. Example D, so this is another problem with a square root in it, so our simplifying will be similar to what we did in the last example. So step 1 is to find f of a plus h. So that's going to be the square root of a plus h minus 7. And you can't simplify that at all, so we're ready to go to step 2. We want to subtract from the result in step 1 f of a, so f of a plus h minus f of a. So that'll be the square root of a plus h minus 7. And then minus, make sure that you put this function in parentheses. So that's the square root of a minus 7. Distributing this negative sign gives us a square root of a plus h minus 7 minus the square root of a plus 7. So with negative 7 and positive 7 cancel, and leaves us with square root of a plus h minus the square root of a. Step 3 is to divide that expression that we just got by h. So f of a plus h minus f of a all divided by h. So that's the square root of a plus h minus square root of a divided by h. So again, we want to get this h in the denominator out of there, and we're going to do that by multiplying by the conjugate of our numerator. So we're going to multiply by square root of a plus h, change the sign in the middle, so plus, and then square root of a. Do that to the denominator as well. Put my tails down behind my square roots. So if we use our formula, when we multiply the numerators, we're going to square the square root of a plus h. Always a minus sign in the middle, and then square the square root of a. This is all over h times the quantity square root of a plus h plus the square root of a. So when we square this, we're just left with a plus h, minus when we square the square root of a, we're left with a. So positive a and negative a cancel, excuse me, and we're left with h over h times the quantity square root of a plus h plus the square root of a. Now we can cancel these h's, and don't forget you're really dividing this h on the top by h. You're dividing this h by h and dividing this h by h. So there's a 1 left on top. So that's really important to remember that there's a 1 left up on the top, and in the denominator we have the square root of a plus h plus the square root of a. And there's our final answer on that one. The next two examples involve fractions, and again with fractions there are some tricks to simplifying this at the end, so that's going to be the big thing with these. So step 1 is to find f of a plus h. That will be 2 over a plus h plus 1. And we can't simplify that at all, so we're done with step 1, so we move on to step 2. We want to find f of a plus h minus f of a. So 2 over a plus h plus 1 minus 2 over a plus 1. So you could simplify this at this point by doing this subtraction. In order for us to do this subtraction, we need to find a common denominator. And so this denominator, even though it looks kind of similar to this denominator, is really completely different. And so the common denominator is going to be a plus h plus 1 times a plus 1. So in order to get the common denominator in our first fraction, we're going to have to multiply this by a plus 1, both the numerator and the denominator. And then minus 2. Here we're going to have to multiply by a plus h plus 1. Now that the denominators are exactly the same, you can do the subtraction. And so on the top, we have 2 times a plus 1 minus 2 times a plus h plus 1. And our denominator is the common denominator, a plus h plus 1 times a plus 1. Now you can distribute this positive 2 and distribute this negative 2. That gives us 2a plus 2 minus 2a minus 2h minus 2. And this is all over our common denominator, a plus h plus 1 times a plus 1. So now we can cancel some things on the top here, and oh, this should have been an A, not an H. Sorry about that. So the 2a and the negative 2a will cancel, and the positive 2 and the negative 2 will cancel. And on the top we're left with, this is a negative 2h divided by a plus h plus 1 times a plus 1. Okay, so now we're on to step 3. And step 3 is to take this expression and divide it by h. So this expression was f of a plus h minus f of a. We're going to take that and divide it by h. So negative 2h over a plus h plus 1 times a plus 1. And we're dividing this by h. So now we have this big ugly fraction divided by h, but h can be written as a fraction. We can write it as h over 1, and when you divide two fractions it becomes multiplication of the reciprocal of the denominator. So this is the same as negative 2h over a plus h plus 1 times a plus 1. So this numerator fraction times, flip this fraction upside down, so 1 over h. And then these h's will cancel, and your final answer will be negative 2 over the quantity a plus h plus 1 times a plus 1. Again, just like with the square root problems, we still have an h in our denominator, but replacing this h with a 0 won't cause me to divide by 0, and so it's okay for that h to be there in that way. In our last example for this lecture, f of x equals 3x over 2x minus 5. So step 1 is to find f of a plus h, which will be 3 times a plus h over 2 times a plus h minus 5. Distribute the 3 in the numerator and the 2 in the denominator. Gives us 3a plus 3h over 2a plus 2h minus 5. And there isn't anything we can do to simplify this, and so we move on to step 2. So we take the expression from step 1, f of a plus h, and subtract off f of a. That will give us 3a plus 3h over 2a plus 2h minus 5, and then minus the function, but only with a's. So 3a over 2a minus 5. So now we can do this subtraction. Again, in order to do the subtraction, we need to find the common denominator, or you can also just think about cross-multiplying. So you're going to take this numerator, multiply it by this denominator, and this numerator, and multiply it by this denominator. So that would be 3a plus 3h times 2a minus 5 in the first numerator, and then minus 3a times the first denominator, 2a plus 2h, minus 5. And this will all be over your common denominator. 2a plus 2h minus 5 times 2a minus 5. Here we'll have to do FOIL, and here we'll just have to distribute this negative 3a. So 3a times 2a gives us 6a squared. And then we have 3a times negative 5, so that's negative 15a. And 3h times 2a is plus 6ah. And here we have 3h times negative 5, which is negative 15h. Distributing this negative 3a gives us negative 6a squared minus 6ah plus 15a. And this is all being divided by our common denominator. 2a plus 2h minus 5 times 2a minus 5. Now we should have some things that will cancel. We have a positive 6a squared and a negative 6a squared. We have positive 6ah and a negative 6ah, and a negative 15a and a positive 15a. So the only thing that we're left with up on the top is this negative 15h. Over our denominator, 2a plus 2h minus 5 times 2a minus 5. And step 3. Step 3 is to divide this expression by h, so negative 15h over 2a plus 2h minus 5 times the quantity 2a minus 5. And we're dividing this whole thing by h, but remember we want to write this as a fraction, h over 1, and then convert that to multiplication. So negative 15h over 2a plus 2h minus 5 times 2a minus 5. And we're going to multiply by this, but flip it upside down, so that's going to be 1 over h, and then these h's cancel. And our final answer on this one is negative 15 over 2a plus 2h minus 5 times 2a minus 5. And that finishes off our lecture about the difference quotient. Let me know if you have any questions, and I hope you're having a great day. Thank you.